Hambini fans, and welcome to another episode of Hambini Reams. In today's episode, Jonas smokes Tadej like Jimmy the Big Boy in the betting shop. Smoking is banned in the UK, I might add, but if you go in certain betting shops, they still smoke. By Hambini, age 5, we better just check that pen is working because we're going to need some major pen action today. Pen is working. Right, disclaimer. I'm an idiot, so make sure you listen to all the wankers in the comments to get the truth. And also go on Weight Wankers because, as everyone knows, everything they say on there is true. Like, some of them say Cervelo make great bikes. As everyone knows, I like jumbo benders. So here is me in Venlo going into jumbo benders. There is some sadistic humour in there. I'll leave that for the commentators. To give you a bit of context, this was making all the news yesterday. So Jonas Vingegaard put in about 1 minute 40 into Tadej Pogacar, who was red hot favourite for this time trial, and well, he just got basically smoked. Pogacar got absolutely reamed. I wouldn't like to be on the end of there. I might, eat my words today, but who cares? So there was a load of comments about that, and there was some more comments. I mean, my Instagram and Facebook lit up like a Christmas tree with regards this, which is the Jumbo Visma Team Car and the number of bikes that were on top of the roof and the distance that it was following from behind. So this is what I lifted from the Escape Collective website, so thanks to them for the picture. I'll give them a credit somewhere. Now, this is Pogacar's team car. I'd say taking a picture of it from the Tour de France coverage. I mean, in the middle of this, there are no bikes. So he's got all his bikes around the outside edges. Nothing really wrong with that. And that's pretty much where you would expect them to be. You're going to get those wheels, those frames off that bike. The nearest one is going to be the one that you're going to use. And he changed his bike. This is Jumbo Visma's team car. Look how many bikes there are on it. So this is the zoomed in view. I mean, there's no way he's going to need 1, 2, 3, 4, 5, 6, 7, 8, 9 bikes for a time trial of this, length. There's just no way. So there is speculation that putting all those bikes on there improves the drag or reduces the drag for Vingegaard. Just to give you a little bit more context here, if you say that is an estate car, so it's probably around about 5 meters long, I reckon he's probably somewhere around 20 to 25 meters ahead of the team car, but I guess that gap can vary. Right. This is a comparison between the two. So you can see the UAE team car here and the Jumbo Visma car here. And there's a huge difference in terms of paraphernalia they put on the top, which is probably completely unnecessary. And obviously Jumbo Visma don't give a fuck about their carbon footprint because, as everyone knows, the more you put on the top of it, the more the drag increases. Now, I'm going to try and explain something here that is possibly slightly complicated for the YouTube masses. The basics of drag, and I do not mean dressing up as a woman. Right, airflow comes in this case, from left to right, and we have Silhouette Man, and it is a man, on his bike. I've drawn this as uniform flow, just for the sake of it, but really there is a bit of swirl and turbulence and road furniture agitating the air before you get there. As he's riding along, he generates a load of vortices and drag that come off the back of it. Now that causes low pressure. So you've got low pressure there and higher, well, this is free stream. Oh, fucking hell. Free stream. As that air comes along, its velocity goes from, let's say, 40 kilometers per hour to 0 on this surface here. By doing that, you generate high pressure, so it's a stagnation point. So you've got HP here, on the back of it, all that air is just going around. I would stress this is a huge simplification because you've also got air going around. But anyway, so high pressure on the front of him and then low pressure on the back. That low pressure is lower than your free stream pressure. So what happens is that sucks you backwards. So if you take, for example, an aircraft wing, flow comes in there and you've got air that comes in that way, air that goes over the top. This air is at lower pressure, so the wing's being sucked upwards. Okay, you've got higher pressure here. And if you read textbooks and things, these things are called streamlines. The more compact the streamlines are together, generally speaking, you're going to get higher pressure. The sort of more gap between the streamlines, the lower the pressure. Right, now the trailing team car. Now what happens here is, we've got the same deal, but now we've got the trailing team car. So the air that comes off the back of him now has to navigate its way over the trailing team car. That results in a lower pressure drop in here. Now you've got, basically, the team car comes along and you've got like a ram pressure increase on the front of the team car. I mean, you probably could say it's something like a bow wave, something like that. So it's squashing the air. That squashing the air is increasing its pressure. So the net thing is you've got a lower pressure drop versus if the team car was not there. Okay, now the factors affecting it, you've got the primary one, which is, oh bollocks, speed. Now the factors affecting it, the primary one is speed. Now because the faster you go, the bigger this gap can be. So we're going to call that the D1 gap. So if you are going at, let's say, 200 miles an hour, you can be a bit further behind or further in front if you're the time trialer to generate the benefit, because that ram pressure is just more energy involved. The other things that can affect it are D2, which is effectively, and this is kind of like linked with the CDs as well, D2, which is the height of the object. So if you make that object much bigger, you can get a bigger increase in pressure on the front of it. And then the final one is CD1 and CD2. So if you were to make this chap extremely aerodynamic and then put a brick behind him, that's beneficial. If you were then to take the team car and make it absolutely streamline, you won't actually get much benefit because streamline objects do not generate that increase in pressure. So the fact they've put the bikes on the top, a bike on the top is nowhere near as aerodynamic as a van. So that's quite a significant difference. I mean, they could have used a van and then just shoved the bikes in the back. I don't know if that's within the rules or not, but having the bikes on top, generating loads of turbulence, loads of drag, and increasing that area, the frontal area, is obviously of benefit. So this is the extreme example. So in this case, matey boy's riding along, and what's happened is we've now got a massive team car. Let's say it's a truck. That can have a couple of benefits. The biggest benefit is you can increase that distance and still get the benefit. So, and I can't actually put a number on this, but if you watch the Yole video, it talks about free stream recovery, which I actually got reamed by some commentators for not knowing what it was about. But anyway, yeah, so you can do that. The other thing is, if you've got like a brick-like object like that, the net drag of the entire system is predominantly on that object. The rider will see the benefit. Right, so how much of a saving is it? Well, if you watched the two of them, Pogacar and Vingegaard, I think Vingegaard probably outdid him in the first corner. I think he got maybe 3 or 4 seconds just in the first corner. He went speeding round there like I've never seen. And I think he's probably gained more than this business with the team cars. I'm not saying the business with the team cars is insignificant, but looking at the length of the stage, the altitude, so the climbing rate, I don't think it would have made that much difference. Now, it's actually very difficult to find data with regards to this. Some punters in the US who watch NASCAR, they think the leading car and the trailing car, when they're together, the leading car has a reduction in drag of about 2.5%. But they didn't quantify how far ahead or behind it was. So yeah, there you go. But at the same time, 2.5%, these things are won and lost by that. The other point is the motorcycles that are, the TV motorcycles, they can have effect depending on where they are, because they generally are a lot closer, but their drag and their CD is a lot lower. So you've got that, the difference. So the team car's massive with loads of paraphernalia on it, and then the bloke with the motorbike with the TV is comparatively small but closer. So yeah, strategic positioning of those will obviously have a difference. I started putting this in there, but free stream recovery, which is really what this is about, if you have a look in the Yoleo disc video, that should cover it. That is the end of this video. If you did enjoy it, remember to smash that like button. If you didn't, go screw yourself. And as always, keep banging your hairdresser.